Hello everyone. So in this lecture video, we're going to be talking about blood typing. We're going to be talking about the ABO blood type, and we're also going to be talking about the RH blood typing. Right. So in this case, so if you're in this case, there's two different blood typing systems that the United States use. One of them is the RH group, and that RH grouping is actually designated by either the positive or negative after a letter. Okay. So in this first section, we're going to be talking about the letter, in this case A, B, and O blood types. Okay, so AB is just A in this case. If like someone just pick it up the hat and says we're going to call this antigens A and B. All right, so there's really no rhyme and reason why this is. Now, when you're very young, none of you actually do not have any antibodies against your own antigens or against anyone else's antigen. It actually takes a while for you to actually develop these antibodies. Okay. But there is a relationship between antigens, which are on the surface of red blood cells, and antibodies which circulate in the plasma. Okay, FYI, antibodies is actually created by B lymphocytes. B lymphocytes, one of the agranulocytes that we talked about previously. Okay, so if you have antigen A on your own red blood cell, you have the opposite antibodies. And the reason why obviously is antibodies actually attach to antigens. So you do not want your own, and if you think about attaching, that's actually like attacking. Okay. So you don't want your antibodies attacking you. So obviously you have to have the opposite. So if you have antigen A, if you're type A, that means you have antigen A. If you're type A, that means you have the opposite antibody, which is antibody B. Okay. If you're type B, that means you have the B antigen, but you have the A antibody, again. And if you are type AB, that means you have both antigens on the surface of your red blood cell. You obviously should not have either antibodies, correct? Because you don't want any antibodies attacking your own red blood cells, right? Now, if you have type O basically, if you think about it, is type 0. That means you have no antigens, A nor B. That means you have both antibodies. So again, there's an opposite relationship between the antigen and the antibodies. If you have type A, you have anti-B antibodies. If you're type B, you have anti-A antibodies. If you have type AB, that means you have neither. Type O, that means you have both. Main distinctions here, okay? So FYI, there are more antigens than type A and type B, okay? But generally speaking, these two types, along with the RH antigen, actually create, in this case, has the highest density, creates the highest density of antigens on the surface of actual red blood cells. So there are consequences when you actually transfuse incompatible blood types. So let's say if you give a type A blood, that means the donor is type A, to someone who's type B, what happens is this antibodies then clump. Okay, they clump. As you guys can see, there's multiple bonding sites here. They clump multiple red blood cells together. And that, in this case, phenomenon is actually called agglutination. Agglutination, basically a fancy term for clumping, right? So you don't want that to happen. And actually, that's actually how you type in the field when you don't have time to ask someone what's their blood type. One of the things that you could actually do is you could actually mix the donor blood or whatever blood you have on your refrigerator and your blood fridge with, in this case, the donor blood, and see if there's actually a clumping. Sometimes the reactions are instantaneous, sometimes they're not. Which brings us to a very important thing, okay? If you look at type AB, folks, I shouldn't say folks, they have no antibodies, okay? And we're only talking about in terms of consequences A and B. So that means to say that type AB, if you're type AB, that means you can receive any blood type, A, B, O. Why? Because you have no antibodies to clump any red blood cells that you receive. So for this reason, type AB folks are actually called universal acceptors. So they can accept any blood. Type O, on the other hand, now again, you are donating red blood cells, folks. You're not donating plasma. This is why they separate plasma from red blood cells. When they transfuse blood, they normally separate the packed red blood cells from the plasma, and then obviously plasma is transfused separately. But anyway, if you receive type O blood, as you can see, there's no antigens. So it doesn't matter which antibodies you have. There is no antigens to clump. to agglutinate. So for this reason, type O donors are actually called universal donors. And again, type AB, no antibodies, they actually can receive any blood, so they're called universal acceptors. Right? So I hope that makes, like a very, like a very clear point, very muddy at this point. So there is another, like in this case, antigen is actually called the D antigen. And the D antigen is, we actually call it the Rh antigen. Okay? So I am O positive. What does that mean? That means to say, folks, if I'm O positive, that means to say my red blood cell has no A or B, but I have the Rh antigen. Okay? If someone is A positive, that means they have two antigens. That means to say that they have both the A antigen and the Rh antigen. If someone is AB positive, that's just unlucky. That means you have all three antigens. That means you have the A, the B, and the Rh factor. Okay, so negative means no Rh. All right, no Rh factor in this case. Now, before, what happens with previously, you are at a very early age, you actually create antibodies, the anti-A antibodies, the anti-B antibodies, okay? But in this case, for Rh factor, you actually do not create the anti-D or the anti-Rh antibody until you're exposed to it, okay? And so this is actually why this is such a very interesting phenomenon, is because one of the problems that actually arises is when, well, for in this case, for pregnant mothers, right? So if your mom is Rh negative, meaning to say that there's no Rh antigen, right? What that means is they have the ability to create the anti-Rh antibody, but they have none yet because they are not exposed yet to the Rh antibody. But what happens if they get pregnant, and they're pregnant, in this case, their baby and their fetus is actually Rh positive. Now, during this actual, before delivery, what happens, I don't know if you know this, is maternal blood and fetal blood actually do not mix because of the placenta. Okay, so in this case, what happens is most instances, there is no interaction between, in this case, this antigens with the mom's blood, so therefore there's no creation of the anti-Rh antibody. During delivery, however, there's mixing of blood or any other mixing of blood altogether, and so mom now creates anti-Rh antibodies. So if the second baby is, in this case, is Rh positive, yes, what happens is blood do not mix, but antibodies can actually cross the placenta. So they can actually attack someone who has the Rh factor, which means they're positive, right? So if your second baby has, in this case, has the D antibody, or the D antigen or the Rh factor, what happens is those antibodies can actually cross the placenta and agglutinate the actual fetus, and then of course the fetus then has distress, and then you have like preterm, all of that stuff, okay? Or in some cases, spontaneous abortion or miscarriage. That's what they actually called miscarriages. So there's drugs, and in fact, interestingly, for these drugs, we don't really know the mechanism of action for this case. We believe that it's because the binding of the actual antibody is actually looser, but we still really do not know how this actually works. And I'm telling you right now, you can read all you want because you won't find a literature that actually explains you what that is. So what happens is, one of the ways that they actually prevent this from happening is they actually give you this drugs. And what this drugs does is they actually, in this case, deplete your antibodies. Okay, so anytime you make anti-Rh antibodies, this to actually clumps it out, and then so if you have an Rh positive baby, well, there's nothing to attack the baby with. Okay, and just to be a preventive thing, if you happen anytime you're an Rh negative, whether your baby is Rh positive or not, sometimes they do precautionary thing and they give you these drugs nowadays, right? So in this case, previously, the antibodies for A and B, you are kind of born with, like very early in your age, you are actually born with those. For anti-Rh antibody, you need to be exposed to it first to actually create the antibodies. Now, creating antibodies for Rh factor is not just a product between a pregnant mother and their fetus. This can actually happen to males, and this can actually happen to males if you are actually given the wrong blood type. Okay, this is one of the reasons why in surgery or in trauma situations, we always give O negative. And the reason why we give O negative is O negative has no antigens whatsoever. So there's no A, there's no B, and there's no Rh factor on the surface of a red blood cell. So therefore, it does not trigger the recipient in creating any antibodies or any antibodies to attack in this case, the donor's blood. Okay, so I hope that makes sense. What's the difference between A, B, and the Rh factor?